Hello, ladies and gentlemen. Welcome to 9.4 Day 2 Force Vectors. Your homework tonight is also Section 9.4, Problems 55 through 61 odd. You should have in front of you a handout about 9.4 Day 2, and you should be looking first at the warm-up. If you haven't already done the warm-up and read the information on the front page, you need to do that now before you begin the rest of this video. So pause the video, take a look at the warm-up, and then come back to the video and start with the force vector on the back. The rest of you, let's go on. Okay, so the first problem that we have here says that we have a force vector of 30 newtons, and it acts on an object at an angle of 45 degrees with the positive x-axis. A second force of 40 newtons also acts on the same object at an angle of negative 60 degrees with the positive x-axis. Find the direction and the magnitude of the resultant force. Question: what is the first thing you should do? Hopefully you answered that with draw a diagram. So I have a diagram prepared for you here. On this diagram, I have drawn in the two force vectors and then the result vector. So the purple line right here is the first vector that has 30 newtons and an angle of 45 degrees. So let's label that as force 1. This vector right here now is the second vector that has a force of 40 newtons and is going in the negative 60 degree direction. I'm using what's called the tip. So here's the tip, here's the tip to tail method. So I'm connecting the beginning of the second vector with the end of the first. And in order to do that, I have to draw in the second XY grid to help me draw the vector in the correct direction. So the second vector is starting at the end of the first and going into its own fourth quadrant. I then go back to the beginning and connect the beginning of the first vector with the end of the second to create what's called the result vector, so FR. I hope that you understand that when you add two vectors together, so in this case we're going to add force vector 1 with force vector 2, so when you add this guy and you add this guy together, we get what's called the result vector. Question: how do you add these vectors together? What do you need to do this? Hopefully what you said to that question was that you need to create the vectors using trigonometry. So here's the first vector. You can see that we put 30 out front for the force, 45 degrees cosine, and 45 degrees with the sine in the j direction to create that first vector. Then I went ahead and I simplified it with my 45, 45, 90 triangle information that I know, and created 15 root 2i plus 15 root 2j. We do the same thing with the second vector. So the second vector then had a magnitude or a force of 40 and negative 60 degree angle. So we take what we know about trig for the negative 60 degrees, multiply it by the 40, and you will get the second force vector is 20i minus 20 root 3j. So now how do I combine these two vectors? What do I do next? Hopefully you said you add the I components and you add the j components. So my I components are here, 15 root 2 plus 20, and my j components were here, 15 root 2 minus 20 root 3. And you have to then simplify these two things. So I went ahead and wrote them in decimals. So 15 root 2 plus 20 gives us 41.213. 15 root 2 minus 20 root 3 gives us 13.428. I am now going to use, this is the result vector, I'm going to use these values to find the magnitude. This is actually the direction. So written in this form right here, this is the direction of the result vector. So it's going 41.213 to the right and down 13.428. Using my Pythagorean theorem, I am going to find that the actual magnitude, or the amount of force that is created, is approximately 43.346. So squaring this number here and squaring this one, adding them together, taking the square root, gives us our magnitude. Okay, next you're going to fill in what static equilibrium is. So there are two parts to static equilibrium. The first part is that the object is at rest. So in order for an object to be in static equilibrium, it means it has to be at rest, not moving. And the second part, which is really where the vectors come in, is that the sum of all the forces acting on the object is 0. So no matter how many forces there are, you add them all up and that will equal 0. So what this really means is that the result force, Fr, will be equal to 0. So we're going to use this type of information to do the next example. So here is example 2. It says that a weight of 500 pounds is suspended as shown. What is the tension, or the magnitude of the forces in the cables? So I want the magnitude of each of the cables. Question: what should you do first? Again, I hope you answered. Draw a diagram. So you'll see that what I did on this diagram is I drew in kind of my imaginary or dotted XY grid, and I made the origin be at the place where the cables came together on the weight. And off to the right here, we're calling this force vector 1. And off to the left, we are going to call this force vector 2. And then this thing down here, going straight down with the weight, will be force vector 3. Question: what should you do next? I hope that you said you should write out each force vector. So there are 3 of them, and you should write each of them out. Before you begin to do this, though, I would like you to remember, I want to point out to you, that when you write out each vector, you have to use the angle off of the positive x-axis. So F1's vector is 45 degrees here, but you need to think carefully about what the angle for F2 will be and what the angle for F3 will be. So think about that and start working on that part first. I'm going to give you a minute. Okay, so here's what I have for my first vector. So 45 degrees, I hope that one makes sense. So we have this 45 degrees off the x-axis. The problem is we don't have a magnitude for that, so I just decided to call it x. You can honestly call it whatever you want. The book will probably call it the magnitude of F1. I just think that gets too sloppy, so I'm going to call it x. And I'm going to go ahead and simplify this out so I don't have any trig in the problem. So that gives me that force 1 is equal to root 2 over 2 xi plus root 2 over 2 xj. What is the angle for the second vector? I hope that you know that the angle for the second vector will be 150. Got some parallel lines going on here, so I have some alternate interior angles. So this 30 right here is equal to this angle down here. So I have 180 minus 30 gives me the 150. Again, I don't know the magnitude of that vector, so I just decided to call it y. You can call them a and b, whatever you like, it doesn't matter. And I'm going to go ahead and simplify this, and this vector becomes negative root 3 over 2 yi plus 1/2 yj. Finally, I need the vector for F3. So you can write this one out. So take a moment to write down the whole entire vector for F3. Hopefully what you wrote is that F3 has 500 for its force. It's the only one that actually has a magnitude. And its angle is 270. So if you wrote it in I and j form with the trig, you would get this cosine 270i plus sine 270j. But if you look at the picture, you might be able to just determine that it's really just negative 500. So you're going in the negative j direction, and that is totally acceptable if you just jump right to this answer here. All right, what are you going to do next? What is the next step? Okay, so Hopefully, you're understanding that you need to add all three of these vectors together. So the first vector, the second vector, and the third vector, and they will all equal 0. They equal the result vector, but that equals 0. So the question is why? Why does F1 plus F2 plus F3 equal 0? And the answer to that is because if an object is in static equilibrium, which this is, it's not moving, then the sum of its forces is 0. So again, that weight is just hanging there and it's not moving. So it means that it's in static equilibrium. So all three of the forces equal 0. So now we have to actually add them together and set them equal to 0. Okay, so when you go to add vectors together, you just take the I components and add them together, and you add the J components and add them together, or you think of it as horizontal and vertical. So this, I dropped the I's and I dropped the J's, I didn't need them anymore. So this is the I component from the first vector, and the I component from the second vector, and there was no I component from the third vector, so that's missing here, it's 0. So first vector, F1, let's actually write this in, okay? So this here was F1's I, and this is F2's I component, and there was no I component from F3. These are the J components, so these are I, let me write this over here. So these are I's, and this row is the J's. Come on. And so this is, again, F1 J component, F2 J component, F3 J component, and each part has to equal 0. So I'm going to go ahead and move this 500 to the right-hand side, and you should create what is known as, what's the word? A system of equations. And not only is it a system of equations, but it's a system of equations that you already did. It was, hopefully you did it because you were supposed to follow the directions and do the warm-up. This system of equations was from our warm-up. So you already did this. So notice I typed them just like we did before on the front of the paper into this 2x3 matrix. So this is root 2 over 2. This is negative root 3 over 2. This is 0. Root 2 over 2, 1/2, 500. RREF with that matrix, and you get these two pieces. Since this right here is the F1 vector, the magnitude of, or the tension, if you will, on the F1 vector is 448.288, let's say, pounds. And the F2 vector is 366.025. What you're going to do now is you're going to do a separate problem to turn in before you leave. So the next problem you're going to get is going to be given to you, and you are going to do it in your groups. Everybody turns one in, and I will be looking forward to grading them tomorrow. Have a great rest of your day.